The Steducentre 2015 Grade 7 A&A Exam Review, Maths. Part 2.
Question 2.1.4, you got 2 to the power 3 times 1 to the power 4. If you looked at the number 8 to the power 2, you'll see that 8 is your base and 2 is your exponent or index or power. The exponent of a number says how many times to use that number in a multiplication. It is written as a small number to the right and above the base number. In this example, 8 to the power 2 is equal to 8 times 8, which is equal to 64. The exponent 2 says that we use the 8 2 times in a multiplication question. Other names for exponents are index or power. So 2 to the power 3 is equal to 8 because 2 times 2 is 4 and 4 times 2 is 8. 1 to the power 4 is 1 because 1 times 1 times 1 times 1 will give you 1. So 8 times 1 and your final answer will still be 8. Some examples of exponents. 10 to the power 3 is the same as 10 times 10 times 10, which is 1000. 10 to the power 2 is the same as 10 times 10, which is 100. 10 to the power 1 is the same as 10 times 1, which will give you 10. 10 to the power 0 is equal to 1. 10 to the minus 1 is equal to 1 over 10, or 0.1. 10 to the minus 2 is equal to 1 over 10 times 10, which is equal to 1 over 100, which is equal to 0.01. 10 to the minus 3 is equal to 1 over 10 times 10 times 10, which is equal to 1 over 1000, which is the same as 0.001. There are exponent laws that need to be followed. So x to the power 0 is equal to 1. An example will be 3 to the power 0 is equal to 1. X to the power 1 is equal to x. For example, 9 to the power 1 is equal to 9. XA, XB is equal to XA plus B. An example will be x to the power 3 times x to the power 5 is equal to x to the power 8. X to the power A divided by x to the power B is equal to x to the power A minus B. For example, x to the power 11 divided by x to the power 4 is equal to x to the power 7. If you have parentheses, x to the power A, close parentheses, to the power B, your answer is x to the power AB. For example, if I had x to the power 5 in brackets to the power 3, it's equal to x to the power 15. If I had xy in brackets to the power a, it will equal to x to the power a and y to the power a. For example, xy to the power 4 is equal to x4 and then y4. If I had x divided by y in parentheses to the power a, it will equal to x to the power a divided by y to the power a. For example, if I had x divided by y in brackets to the power 6, it will equal to x to the power 6 divided by y to the power 6. If I had x to the minus 1, it will equal to 1 over x. So if I had an example, 3 to the minus 1 is equal to 1/3. X to the power minus a is equal to 1 divided by x to the power a. So if I had 9 to the minus 2, it will equal to 1 over 81. The 81 would have been because of 9 to the power 2, which is 9 times 9, which is 81. X to the power 1 over n is equal to the root of n with x inside the root. For example, x to the power 1/3 is equal to the cubed root of x. If we look at the last example, x to the power 9 over 2, it will equal to the root of x to the power 9, which is equal to the root of x in parentheses to the power 9. It's very important to know the laws of exponents in order to do any of the exponent calculations. 2.1.5. Find the square root of 144 plus 6 squared. The square root of a number is a value that when multiplied by itself gives the number. For example, 4 times 4 is 16, so a square root of 16 is 4. Note that minus 4 times minus 4 is also 16, so minus 4 is also the square root of 16. The symbol root means that it is a positive root. Let's look at some examples. The square root of 1 is 1, since 1 squared is 1. The square root of 4 is 2, since 2 squared is 4. The square root of 9 is 3, since 3 squared is 9. The square root of 16 is 4, since 4 squared is 16. The square root of 25 is 5, since 5 squared is 25. The square root of 36 is 6, since 6 squared is 36. The square root of 49 is 7, since 7 squared is 49. The square root of 64 is 8, since 8 squared is 64. The square root of 81 is 9, since 9 squared is 81. The square root of 100 is 10, since 10 squared is 100. If the square root of 144 is 12, 6 times 6 is 36,
then 12 plus 36 is 48.
2.1.6, 3 over 5 times 7 over 6. When dealing with fractions and multiplication, it's important to know the rules. Multiply the numerator, multiply the denominators, reduce the fraction if necessary. So 3 times 7 is 21, 5 times 6 is 30, 21 over 30 reduced is 7 over 10. 2.1.7, 0.012 divided by 4 is how much? A decimal is a fraction whose denominator is 10 or any power of 10. Many fields use the metric system of measure, which is the decimal system. At times, it is necessary to change a fraction to a decimal to simplify a procedure. Calculations using decimals are accomplished in the same manner as with whole numbers. The difference is the decimal placement. Placing each decimal point in its correct location is critical for accurate calculations. 0.012 divided by 4 is equal to 0.003. 2.1.8, 100 minus 12 divided by parentheses 8 plus 4 close parentheses. BODMAS is important and needs to be followed. B for brackets, O for orders, DM for division or multiplication, and AS for addition or subtraction. So, in the question, we will do what's in brackets first, 8 plus 4, which is 12. We will then do the division. 12 divided by 12 is 1. We will then do the subtraction. 100 minus 1 is 99. Question 2.2. Write 1.6 as an improper fraction in the simplest form. An improper fraction has a numerator which is greater than its denominator. And if I wanted to write a decimal as a fraction, I will sit and say 0.6 is equal to 6 over 10. You will divide by 2 on the top and divide by 2 at the bottom, which will give you 3 over 5. In the question, we have 1.6. As a mixed fraction, that will be 1 and 6 over 10. As an improper fraction, it will be 16 over 10. And simplified, it will be 8 over 5. Question 2.3. A group of 25 grade 7 learners watched a soccer match. The ratio of the number of boys to the number of girls was 2:3. How many boys were there? A ratio compares numbers in a set order. For example, in this little block, the ratio of men to women is 3:1. The ratio of women to men is 1:3. In our example, we are given a class of 25 students. The ratio is 2:3, so there are 5 parts. So 25 divided by 5 is 5. So the number of boys is 2 boys for each of the 5 groups, which will equal to 10. The number of girls is 3 times 5, which is 15. So there are 10 boys and 15 girls, 25 in total. But the question asked, how many boys were there? So there were 10 boys. Question 2.4. Calculate 10% of 15 Rand. Percentages are a way to work out part of a number, such as 75% of something, which is 3/4 of it. The sign percentage stands for percent, which means out of 100. So 10% of 15 Rand is 1 Rand's 50. Question 2.5. John traveled by car at an average speed of 80 kilometers per hour for 4.5 hours. Calculate how far he traveled. If he was going 80 kilometers per hour for 4.5 hours, 80 times 4 plus 80 times the half is going to give you 320 plus 40, which is 360 kilometers. Question 3.1.1. Fill in the missing numbers in the following number sequence. 1, 4, 9, space, 25, space. And 3.1.2. Are the numbers in the above sequence prime numbers, square numbers, or cubic numbers? What is a prime number? A prime number is a whole number which can only be divided by itself in 1. A prime number must have exactly 2 factors. What is a square number? It's numbers which can be arranged in a square shape. For example, 1, 4, 9, 16. What is a cube number? 1 is the first number in your cube number. It's numbers which can be arranged in the shape of a cube. The next is 8, the next is 27, the next is 64. In our question, the missing numbers is 16 and 36. These are square numbers. Question 3.2. Study the following diagram pattern of regular octagons and then complete the table. So, we have 1 octagon, then 2 octagons, then 3 octagons. The number of sides is 8, then 15, and then 22. What we can see is that it is increasing by 7 each time. So your next number is 29. If you wanted to work out your Tn formula, it will be 7n plus 1. Question 3.3. Use the given rule to fill in the missing values in the flow diagram below. The rule is T is equal to 2 times P minus 3, and you need to answer 3.3.1, 3.3.2, and 3.3.3. 3.3.1. T is equal to 2 times P minus 3, where P is 11. T is equal to 2 times 11 minus 3. T is equal to 22 minus 3, so T is equal to 19. 3.3.2. 21 is equal to 2 times P minus 3, which means we need to solve for P. If we take the 21 across, it becomes 2 times P minus 3 minus 21. If you simplify, it is 2 times P minus 24. That means that if we divide by 2, P will equal to minus 12. So, P is equal to 12. Question 3.3.3. T is equal to 2 times P minus 3, where P is 20. T will equal to 2 times 20 minus 3. T is equal to 40 minus 3. T will equal to 37. Question 3.4. Calculate the value of C cubed plus 12 if C is equal to 3. BODMAS is very important. We need to always start with brackets, then orders, then division or multiplication, and then addition or subtraction. And when we're working with an exponent, we need to remember that it has a base, an exponent, or index, or power. The index of the number says how many times to use that number in the multiplication. So 3 to the power 3 is equal to 3 times 3 times 3 plus 12. So it will give us 27 plus 12, which is 39. Question 3.5. Solve the following equation by inspection. 3.5.1. K over 3 is equal to 9. 3.5.2. Y minus 17 is equal to 13. The first one is an improper fraction. 9 times 3 is 27. So 27 divided by 3 is the same as 9. Y minus 17 is equal to 13. If I take the 17 across, y is equal to 13 plus 17. So y is equal to 30. It is important to remember that when a sign goes across an equation, its operation will change. Addition will become subtraction, subtraction will become addition, multiplication will become division, division will become multiplication, the square root will become the square, and the fraction will become its reciprocal.
Thank you for watching the Steducentre, turning ordinary learners into extraordinary leaders.